do the graph every time. There's a ton of edges to make with the forward edges and the reverse edges, and setting up all these classes. All the classes have so many fields, so all of that takes a while to set up. But once you get all of that set up, the main goal of this lab is to get a word and see if you know how to spell it or not. So to do that, this is where I use Can I Spell. So Can I Spell calls breadth first search. And it will call it over and over and over and over again until you can't find any more paths. So the first time we look at Can I Spell, it's going to go into breadth first search. And let's say we go from the source. The first edge on the adjacency list is going to go to ENG. And let's say, of course, breadth first search is just going to go to SAA and PRR and EAE. But to shorten my explanation up, let's just say it'll go to ENG and then G and then sync, and then it found a path. We got to the sync. Breadth first search is going to return 1 because we found a path. And so once breadth first search returns, let's see, I'm going to delete this, erase this. Once breadth first search returns, you are going to follow the back edges that have been set in breadth first search and follow those back edges and change the values of these guys, original and residual. So this is where it gets kind of complicated. I'm going to write a few things down so we can all be clear on this. Is everyone good with the no class? I'm going to have to erase it for room's sake. Everyone got that down? Okay, so we're looking at Can I Spell. So Can I Spell calls breadth first search over and over until you can't find paths anymore. So this should be easy to implement because you can just make breadth first search, return 1 if you found a path, return 0 if it doesn't. So you can have a while loop of just calling breadth first search. And in that while loop, have the condition of while breadth first search found a path, it returns 1, then do all this stuff. So when you call breadth first search, it returns a path. You're in that loop to do stuff with that path. And we're going to change all these values over here. Once breadth first search returns with a path found, follow the back edges from the sync to the source. So again, the back edges will be set in breadth first search. While changing the original and residual values along the way on both normal and reverse edges. So that the original is equal to 1 and residual is equal to 0 on a normal edge and flip-flopped on a reverse edge. So this is representing the backflow. We found a path, and it says, while we're going back through that path, we're going to follow the back edges from the sink to the source. And on the normal edges, remember we set up having the original as 0, and, the original 1, the residual 0, and now we're changing it. Original is going to be 0 now, because we've been down that path, we've used it up. The residual is 1, but on the backflow, the original is 1 and residual is 0. The reverse edge. On the reverse. So that way, when you're doing breadth first search, if you only follow paths that have original equal to 1, you should never follow a path that you've already done before because of these changes. And you don't ever see it in one of these examples, but I think you guys probably remember in class graphs where it looks kind of strange, but to find an augmenting path, here's the source and here's the sink. For some reason you had to, for some reason you had to go here and then here and then here and then here and then here. Remember seeing those examples in class? I have an example of an augmenting path that it was hard for me to think of one off the top of my head with this, but I found one in my notes of another path that I might show you guys where you go backwards to actually find the path. You need to have the reverse edges set up so you could use them potentially to go back to find a path. And if you set it up this way, it'll work. Because that way in breadth first search, you only follow paths where original is equal to 1. And doing this, you will never return a path or choose a path you've already been on. You will never choose a path you've on. So this only works if you have the normal edge and the reverse edge. And on G, on a G's adjacency list, you don't include edges that come into G. G's adjacency list would only have this reverse edge going back to E and G, and then the forward edge to the sink. So that way, for some reason, if you need to go backwards, I'm saying backwards in quotes, not be confused with the reverse edges and stuff. But if you had to make some sort of path like this, where you went and backtracked to go forward, then you would be able to follow whatever way you got to G and then to go back through a reverse edge. And you might need this reverse edge to find the augmenting path. So again, the only way this works is on your adjacency list, the edges that come from G's adjacency list should only be going with the word node to the sink and to the reverse edge back up to the dice where it came from. So this edge, E1, is not going to be on G's adjacency list because it's a 2 point on E1. Yeah.
So does that mean for every node, on every node's adjacency list, we don't include edges going into that node?
Exactly. Don't include the edges going into it. The adjacency list should only have the edges going out of it. Where out could be these reverse edges too. And that way, with this setup, you'll be able to backtrack if you need it. Okay, so let's see. So when you found the path, you follow the back edges from the sink to the source while changing the original and residual on both the normal and reverse edges so that original is 0 and residual is 1 on a normal. And then you go to the reverse edge for, let's say we found the path. Is the RPRR? R.
Choose.
Force and sink. So when I follow the back edge, let's say this is the back edge that led me from R to the sink. So I take this edge and change its original to 0 and its residual to 1. And then I look at this edge's reverse edge, and I have to take the reverse edge and make its original 1 and its residual 0. And as you're following the path, maybe that path took a weird way like this, and you don't know if the back edge was going forward or backward through the graph. It doesn't matter as long as you follow these rules. And you have your adjacent t-list set up right. Alright, so that way in breadth first search, everything will work. You'll never choose a path that you've already been on. And then eventually you won't be able to find any more paths on breadth first search. So once breadth first search can no longer find any more paths, find new paths, then you're going to be exiting out of that while loop that does all of this stuff. And we're going to check all of the nodes that go from RAGE to the sink. So I'm going to take my word nodes, look at all of the edges that go to the sink. And if the residual is 1 for every single edge that goes from the word node to the sink, then you can spell the word. And can I spell returns 1. That means I found a path, and remember we changed original to 0 and residual to 1 on the forward edge if we found the path. So if we found a path to take all of these letters to the sink, then all of these residual values going from R to sink and from A to sink and from G to sink and from E to sink should be 1. So check all these residuals. If every single one of them is 1, you can spell the word. Can I spell returns 1? You save all of the, I saved all of the dice nodes that I used in spelling IDs to print. And once breadth first search can no longer find new paths, just to repeat that, check all the word nodes to see if the residual equals 1 going to the sink. And if all of them do, you can spell the word. So one tricky thing, a lot of this is tricky, but another tricky thing is when you use breadth first search, you have to clear the back edges every time, right? Because you are just using back edges for that particular path that you found on breadth first search. So at the beginning of breadth first search, you have to clear the back edges every time. I would do that just right at the top of breadth first search, go through all the nodes, clear the back edges, set all the visiteds back to 0, because you're going to be doing breadth first search over and over and over again. But one thing that's a problem is that the back edges you would think would tell you, oh, that'll tell me what dice I used to spell this word. Not true, because you cleared it out a lot. So what you have to do is something a little more complicated, since the back edges can't be trusted anymore. And you have to look at the word node and use the edge from the adjacency list on this word node that has an original of 1. Because an original of 1 would be the reverse edge that goes back to the dice node that you used. So if you take a look at the word itself, because you have to take a look at the word node, check to see if going to the sink, the residual is what? What are we looking for the residual here to be? 1 or 0? 1, yeah. We want the residual to be 1. So you can go ahead and check that. And then while you're at R, go ahead and see, okay, where's that edge where the original is 1? And that'll be where the dice node is, that 2 location. So while you're at R, go ahead and see what that dice is. Go ahead and put it on spelling IDs. You don't know if you can spell the word yet, because you haven't gone through A, G, and E. But that way you're doing it one by one anyway, and if you get all the way to E and they all have a residual of 1 going to the sink, then you've found the dice along the way. So that's a little bit tricky. So I have, let's see, one example